In 3.2, we are going to talk about proving trigonometric identities. So the main three things we're going to be using is that tangent is sine over cosine, cotangent is a reciprocal, so it's cos over sine, and then we're going to be using these Pythagorean identities, which you have to memorize. Sine squared plus cos squared equals to 1. Sine squared x plus cos squared x equals to 1. Now, if you have sine of x plus cos x, that does not equal to 1. But sine squared of x plus cos squared of x equals to 1. Now, if you manipulate this a little bit, you take sine squared x plus cos squared x equals to 1, and you subtract cosine squared of x from each side, then we're going to get sine squared of x equals to 1 minus cos squared x, which is how we get the second identity. And then similarly, cos squared x equals to 1 minus sine squared x. Here are some rules to proving identities. Number one, you can only work with one side. So once you start with one side, you cannot even touch the other. Then you have to make that side look like the other side without actually touching the other side. A big hint is always rewrite tan x and cotangent of x in terms of sine and cosine. So tan x would be sine x over cos x, cotangent would be cos x over sine x. Often we need to get a common denominator, and then we would often use one of these Pythagorean identities. So we're going to do some of these problems in this video lesson. Some of them we're going to save for class. So number one, it says we have to prove that sine of x plus cotangent x times cos x equals to cosecant of x. Now let's follow the rules. Number one, only work with one side. So we always choose the side that's more complex. So we're going to choose the left side. And then we're going to say, okay, rewrite tan x and cotangent of x in terms of sine and cosine. So let's go ahead and do that. Sine of x, can't really do anything with that. But cotangent is going to be cos x over sine x times cos x. And anytime there's one fraction, I recommend making the other term also into a fraction. And we want to show that it equals to cosecant of x. We can't touch the right side at all. Then we can, so in multiplication, you don't need a common denominator. So we have sine x. Cos times cos is going to be cos squared x. Sine x times 1 is going to be sine x. And anytime there's a fraction, make the other expression also into a fraction. Now the third step says get a common denominator. So between 1 and sine x, the common denominator is just going to be sine x. So I'm going to multiply the first fraction by sine x over sine x, so I can make this 1 into a denominator of sine of x. So then this gives us sine squared of x over sine of x plus cos squared of x over sine of x. And we still want to prove that this equals to cosecant of x. Now that we have a common denominator, we can write these as sine squared x plus cos squared x. And we want to show this equals to cosecant of x. We have our Pythagorean identity, which we're going to use quite a lot. Sine squared x plus cos squared x equals to 1. So this gives us 1 over sine x. And guess what 1 over sine of x is? That is equal to cosecant of x. Therefore, we prove this identity. So for a lot of these, it's a matter of taking the tangent, cotangent, rewriting it, multiplying, getting a common denominator, and going from there. Let's take a look at the next one. We got cotangent squared of x. So we know that cotangent is cos x over sine x, but because it's squared, this is going to be cosine squared of x over sine squared of x plus 1. And we want to show this equals to cosecant squared of x. Now I'm going to write this as 1 over 1. Let's get a common denominator. I want to take the 1 and I want to convert that into a sine squared x. So the only way to do that is to multiply the second fraction by sine squared x. And I should have left myself a little more room, I'm sorry. So I want to take the denominator of 1, convert that into a sine squared x. So I multiply this by sine squared x. So if I multiply the denominator, I got to multiply the numerator as well. So I have cosine squared of x. 1 times sine squared of x is going to be sine squared of x over sine squared of x, and I want to show this equals to cosecant squared of x. Now we know that cosine squared plus sine squared is 1. So I have 1 over sine squared of x. Guess what 1 over sine squared of x is? We know that 1 over sine x is equal to cosecant of x. That's one of our trigonometric identities. So 1 over sine squared of x is going to be cosecant squared of x. Let's do another one. We have tan squared x plus 1 equals to secant squared of x. So once again, let's take our tan squared x. And we know that tangent is sine over cosine. Tan x is equal to sine x over cos x. So tan squared of x, this is going to be sine squared of x over cos squared of x plus the one I want to write as 1 over 1 equals to secant squared of x. Now once again, I want to get a common denominator. So to make the 1 into a cosine squared, all I have to do is, I have to multiply this 1 by cos squared of x. Okay, so now I get sine squared of x over cos squared x plus cosine squared of x over cosine squared of x. And I want to show that this equals to secant squared of x. So my common denominator is cos squared x. So sine squared and cos squared, I can rewrite them as under one denominator. That's an identity. Sine squared plus cos squared equals to 1. So I have 1 over cosine squared of x equals to secant squared of x. 1 over cosine squared is secant squared of x. So we are done. Number 4, this one is I think a little more complicated. We have 1 over sine squared x minus 1 over tan squared x equals to 1. So the first fraction we can't do much with. I'm going to leave that as 1 over sine squared of x. Now the tangent is going to be sine over cosine. Always replace tangent with sine over cosine. And because it's a square, it'll be sine squared x over cos squared x, and that equals to 1. Now remember that you can't divide by a fraction. So instead, we are going to multiply by the reciprocal of that fraction. Since we can't divide by a fraction, we are going to multiply by the reciprocal. So we have 1 over sine squared of x minus, this is cos squared over sine squared. And that equals to 1. We already have a common denominator, so we don't have to do anything there. We already got a common denominator of sine squared of x. On the numerator, I have 1 minus cosine squared of x. Now let's go back to our identities. 1 minus sine squared of x, guess what it equals to? It equals to cos squared of x. So 1 minus cos squared of x equals to sine squared of x. 1 minus cos squared of x equals to sine squared of x. So I'm going to replace 1 minus cos squared of x into sine squared of x. And sine squared x over sine squared x is 1. Therefore, 1 equals to 1. And we are done. Numbers 5 and 6 we will do in class.